Hello, my technical drawing and design class. So today we're going to build some realistic threads, and I'm going to show you not only how to do this in Inventor, but I'm also going to show you how to read the chart so that you can design a thread based off whatever thread count you want and have it realistic in Inventor. So as you can see right here, this is an example. This is a trailer hitch, and we have the realistic threads. This is what we're going to be working on today. So to start, I'm going to go ahead and file new, new from template. Let this open up. I'm just going to go ahead. We're going to do this in inches. So I have English set up here. This is going to be a part, standard, and create. And here we go. It's going to open us up right up to a sketch. So the first thing I want to do in here is I'm going to build the head to the sketch, to the bolt here. We're going to do a 1-inch diameter post to this, and we're going to put a 2-inch head on here that has a hex head with a tapered edge. So let's go ahead and do the head first. We're already in a sketch. So if you have rectangle in here, grab the drop down, grab polygon. We're doing a hex head, so it's 6-sided. I'm going to come right here in the middle with my cursor, so I now have the green dot. Lets me know I'm right there in a lock-on spot, which is the middle of this. I'm just going to click and press escape. Now I need to put 2 dimensions in here. I need to give it the size, and I also need to constrain this thing. So first, let's get the dimensioning here, this constraint. Again, I want to have a 2-inch head on this thing, and I'm going to constrain this side. So it's vertical. Perfect. I can see down here in the bottom corner, I'm fully constrained. I am going to, looks good, finish sketch. I am a big proponent on naming all of my layers. So if I have to go back and change anything, it's very easy to. So let's go ahead and change this to uh, head sketch. Sounds good. Head sketch. Okay. And now let's go ahead and extrude this thing out. We're going to grab it here, grab that face, and I think I'm going to have the distance of this head, or the thickness of it, we're going to do a 1/2 inch. So 1/2 inch head, perfect. Just like that. We're going to name our extrusion bolt head. Perfect. Now we're going to go ahead and put the taper on there. So we're going to start another sketch, go right to this face. That's where we're going to have this thing attached to. I need a circle. I'm going to click on this, and then I'm just going to click on the edge here. And you can see it show up at 2 inches right there. So I can click, and when I press escape, it is going to tell me that it's fully constrained because I got to the edge here, so I'm good to go there. I am going to finish the sketch. I'm going to rename my sketch bolt head taper sketch. Now we need to extrude this. So again, we're going to grab the extrude. The face, we want to grab that circle that we just did. Now we're going to change a couple things in here. I want to change my distance A here to through all. You can see it pushed it backwards now. I'm going through, which is perfect. For my output Boolean, I want this to be intersect. So only where this thing intersects is what's going to go away. And finally, my taper, I want to set this at 45 degrees. And you can see it's giving me a nice little taper right here. That's exactly what I wanted. Looks beautiful. And I'm going to rename this bolt head taper. Perfect. All right, now we're going to start to build the post. That I want to be on this face here. Let's start a sketch. Come right here. We're going to again work off the middle. So I'm going to grab my circle tool. Click right in the middle. I have my green dot. Very good. And I want this to be a 1-inch diameter post. Perfect. Finish the sketch. I am going to rename the sketch. Post sketch. Works. And then I need to extrude that. So I'm going to extrude this, and we're going to make this post. Let's make it 2 inches. Let's make it, yeah, 2 inches sounds good. So I'm going to do a 2-inch. It's going to come off the face here. My Boolean, I want to join. It's exactly what I want. Taper, I do not need any taper because I want a nice straight post. So we'll say OK. Perfect. Now let's go ahead and edit this slightly. We're going to do a fillet on the edge here. This looks like an 1/8 inch fillet. I think I'll stay with an 1/8 inch. That's fine. Put an 1/8 inch there and right here. Perfect. So I now have smooth edges to the front and going into the bolt head. Perfect. All right, so at this point, now we need to go ahead and start building the threading. To do this, I'm going to jump over into this document here, and I'm going to show you how to read this thing. First off, to know how our threads are going to go, we need to figure out the pitch on this thing. A pitch is very simply, for us, by the way, we're going to be working in millimeters. I could do this in inches since I'm building a whole bolt head in inches, but I want you to be able to work both ways. And a lot of times when you see specification charts, you see these in millimeters. So that's what we're going to work off of. So we are working with a 1-inch bolt. Number of threads for our bolt is going to be 8. I want to do 8 threads per inch. So to convert that into millimeters, which is going to give us our pitch here, we're going to take 25.4 and divide it by n. And you can see it right over here. Like I said, number of threads per inch will be 8. My pitch being 25.4 divided by n. So let's go ahead and bring the old calculator up real quick. Calculator. So we have 25.4 divided by 8, because 8 is my n, equals 3.157. Perfect. Copy. There, and this is in millimeters. Next, the height that I have is going from the peak to the valley. And the reason I say peak is up here and valley is down here is because we're dealing with a male screw. If we are dealing with maybe the bolt or the nut side of things, and we have the threading on the inside, that would be the female screw because that's what it would be going into. So the male screw here is we're dealing with the lower half, which makes on this thread right here, the peak being at the top, the valley being at the bottom. My height is that distance. So to get that, we have height is 0.866025 divided by n times 25.4, which is, I should say times 25.4. Okay, so let's go ahead and pull our calculator back up again. And we're going to go with 0.866025 divided by 8. That's our number of threads. And all of that multiplied by 25. This gives us 2.749629375. This is our distance for our P or our pitch in millimeters. So I'm just going to grab this and I think I'm going to take it to 4 degrees of confidence, or 4 degrees here. So copy 0.7496 millimeters. The wrong spot, didn't I? There we go. Millimeters. Perfect. That gives us our height. right there. Now, what we're going to want to do is on the peak here, we do not want this to come all the way to a direct point, nor do we want the valley to come all the way to a direct point. Reason for that is if we had any type of manufacturing imperfections, this screw would not work. You would also have to deal with air gaps and things like that. So we round these things off. We will be doing a fillet at the valley, and we will be actually doing a camber or chamber at the top to round off those. So first, for the peak, what we need to do with that is shows it right here is this is h divided by 8. So I should actually just do it right here. H divided by 8 equals, and for this is going to then be 2.7496 divided by 8. So 0.3437. 0.3437 millimeters. Next, the fillet that we're going to be doing in the bottom. This is the height times or divided by 4. You can see it right here. I could just double this and that would be the same thing, but just so we keep our math consistent, we're going to go with, once again, our initial height, 2.7496 millimeters, and I will divide that by 4. That's going to be 0.6874. Copy, paste, millimeters. All right, so that is all of the math that we need to do. We're going to pop back and forth with this, but this is giving us our numbers to now design our thread. So back in here into Inventor, I will open up my origin so I can see my planes. What I'm going to look for is the plane that is we're running right through here. We're going to work off the top. So I want to see, you're going to see a green box that comes directly through here. So it is not my XY plane. It looks like my XZ is exactly what I'm going to want, not my YZ. So very good. I'm going to be designing off of the XZ plane for this one. So start sketch, XZ plane, perfect. And I'm going to zoom in over here a little bit. First thing I want to do is draw a triangle. 3 sides, perfect. With a vertical line coming from one point up through the middle. And I want to hit the midpoint, so I look for the green dot to show up right through the point. Perfect. Press escape. Now I want to constrain this a little bit. So let's go and constrain that so I have a nice vertical line. Let's constrain this one so I have a, oops, horizontal line. Try this again. Line. And then another line from here up. There we go. Sets that one. There we go. And we set it. Now I have these two constrained. Now I need to dimension this thing off a little bit. So first let's start with the pitch, which is what this line will be right here. Go back to our notes. And our pitch is 3.175 millimeters. So let's dimension that. 3.175 millimeters. Ooh, they moved it way over there. Let's bring it back over here. Thank you. Now, so 3.175 millimeters equals 0.125 inches. It automatically did that for me. Good. Next, I need to have this angle set. It's actually going to figure out all the other information for me of the height, which would be nice. So come back to this document right here. And I can see that it's a 60-degree angle between the two. So I'll come back over here, dimension, 60 degrees. There we go. Have my triangle the way I want it. Next, I am going to draw a line from this corner. I want to make sure I get on the endpoint, so I turn green, over to the post after I get past the fillet, and I am looking for, there we go, that green dot. Got it. Perfect. Press escape, and I want to constrain that so it's nice and horizontal across. Perfect. And then, let's see here, a couple other things. I want to take this line here, turn it into a construction line. Does not need to be a real line. And this vertical line, I want that to be a construction line as well. So I now have everything opened up. And I am going to dimension this part here. I like to use this on a number that's easy for me to remember. So I'm just going to go 0.25. So it puts me a quarter inch off. Perfect. And you can see I have a fully constrained sketch here. So finish sketch. There it is. I'm going to name this thread design. Just like that. And again, if you can look through here again, I have bolt head, I have the head taper, and that has things called extrusion. If I was coming back through or if someone else is working behind me, they would have no idea what this is. I just happen to know that that's the post. So I am going to name that. Should have done before. Okay. And then these are the post fillets. Perfect. Now everything looks good. All right, so now what we're going to do is the actual threading itself. So what I want to do is a coil. And I already grabbed the profile for, oh, sorry. I almost missed something. Let's go back to our thread design. One other thing I did forget in here, and that was to do the fillet down here. Can't believe I almost forgot that. The fillet is right here, 0.6874 millimeters. I'm just going to copy that real quick. Grab my fillet tool. I type that in there, 0.6874 millimeters. Come back. It already has that designed. And there we go. Now we have that. Now we can come back and finish that sketch. That way we have that nice smooth valley in there. Now, coil. I have my sketch already set up as the profile. My axis, what I want is to have a green line show up right through the middle of this thing so that way we can cut through it. So when I go to select my axis, I start looking for these things. My x-axis does not show up. It's going vertical between the post and the head. The y-axis, I don't even see that one, but the z-axis for mine is going right through. You see that little green line is going to show up here as I hover over top of the z-axis. So I will click that, and there's my coil. If your coil is going the opposite direction, just flip the direction. For my pitch is right here. We use the exact same number, 0.125 in inches. So I can just copy that, put it right here. For the height, that's how far up the bolt we want to go. Maybe we don't want to go the whole way up. Maybe we want to stop slightly short. We can do that. I think for mine, I am going to go ahead and go with the with the 2, which is the full way up, plus the width of my pitch. So 2.125. I'm going to make this a right-handed screw. So I leave it on right hand. And my Boolean, I go with cut. When all is said and done, oh, check that out. We have a realistic thread. Now, the last thing I want to do is I want to knock off the tips of these peaks. So we're going to go with camber. My distance, oops, is right here, which is the peaks. We're knocking off 0.3437 millimeters. Copy that. Paste that in there, say millimeters. Grab this edge and then apply it. And now if I look at this, I have a neat little screw. I have tips rounded off. I have a valley in here, so I'm good there. I have a tapered front edge, so I look good to go. I have a bolt head that's tapered off the front, and that is how you do a bolt with realistic threading. If you have any questions, please let me know. Otherwise, thank you for watching.